selections. So NCR's formula is n factorial by n minus r factorial into r factorial. Neha, do you know this before?
Yes, sir.
Okay. So usually what we do is, see, first you try to understand what n factorial is. What is n factorial? N into
n minus 1 factorial n.
So on up to 3 into 2 into 1. Okay. N
Yes,
factorial is the product of all the numbers starting from n going back to 1. Okay. And n factorial can be written as, see, n into n minus
1 factorial.
If you feel lazy, you don't want to go till 1, you want to stop at n minus 1, you can write factorial here in the last number. Does it work?
Yes, sir.
Because if you take out n, the remaining part is n minus 1 factorial. If you want n into n minus 1 into n minus 2, if you want to stop here, you just have to put a factorial at the last number. Okay.
Yes, sir.
So n factorial can be written like this. Second, what is NPR? NPR means usually n factorial by n minus r factorial. Okay.
Yes, sir.
But when you calculate it, what I usually do is starting with n, write r numbers. This is how I usually calculate NPR. What is it? Starting from n, write r numbers. For example, 10 factorial is 10 into 9 into 8 into so on up to 3 into 2 into 1. You have to multiply all of them. Okay.
Yes, sir.
What is meant by 10p1? Starting with 10, you write only one number. So 10p1 is 10. 10p2 is starting with 10, write two numbers. 10 90. You understand?
Yes.
10p3 means starting with 10, write three numbers. 10 into 9 into 8 is 720. Do you understand?
Yes, sir.
And third, NCR. NCR is NPR by R factorial. Is it? Yes or no? N factorial by n minus r factorial is NPR, right?
Yes, sir.
So what is NPR? Starting with
n and
r number by r factorial. Do you understand?
Yes, sir.
Starting with n, write r numbers by r factorial. Okay. This is a shortcut to find NCR when you do the calculations. Okay. For example, what is 10C3? See, I don't always write the formula and waste my time.
10 into 9 into 8 by
divided by 3 into 2 into 1, 3 factorial. You understand? So 120. Yes. What is 11C2? Simply 11 into 10 by 2.
Into 10 by 2.
55. Do you see? Is it clear?
Yes, sir.
So first you need to understand how to easily find NCR. And once you understand NCR, let us try to understand this formula. What is the formula? X plus y whole power n is equal to, what is it? NC naught x power n. That's the first term. Okay. The first term contains complete x to the power n. And as you go forward, the power of x decreases by 1 unit and power of y increases by 1 unit. Do you understand?
Yes, sir.
Slowly the power of x decreases. N minus 2 y square. NC3 x power n minus 3 y cube.
Y cube. Yes.
So as the power of x decreases and decreases and decreases, finally
y becomes,
power of x completely disappears and complete power of y comes. Okay.
Okay, sir.
So let us take an example. What is x plus y whole power 4? It is nothing but 4c naught x power 4. Okay.
4c1.
4c1. The power of x decreases, the power of y increases. 4c2 x square y square. 4c3 x y cube plus 4c4 y to the power
y power 4.
Now, x plus y whole to the power 5. 5
is not x power 5.
Okay. Yeah, Vishal, anything you want to ask? But plus 5c2 x cube y square plus 5c3
X square y cube.
Yeah, x square y cube
5c4 x y power 4
plus
5c5 y power 5.
Okay. Yep. Now, if you want to find these numbers 4c1, 4c2, 4c3, 4c4, 4c5 are there, right? 4c4. Okay. 5c0, 5c1, 5c2, 5c3, 5c4, 5c5. These are called binomial coefficients. Okay. Binomial coefficients. Okay. So if you know how to find binomial coefficients easily, expansion of x plus y whole power n is very easy, right?
Yes, sir.
See, I have told you the shortcut of finding NCR, right?
Yes, sir.
So there are some extra properties of NCR which will be useful for you. Okay. For example, the first property is NC0. NC0 is always equal to NCN is equal to 1. Okay.
Okay.
For example, what is NC0? N factorial by n minus 0 factorial into 0 factorial. Right? Is it correct according to the formula?
Yes,
N
sir.
minus 0 factorial is n factorial. This n factorial and this n factorial gets cancelled, right?
0 factorial is 1.
0 factorial is defined as 1. Okay. So this is 1. And what is NCN? NCN is n factorial by n minus n factorial into n factorial. Right? Now this becomes 0 factorial, this n factorial gets cancelled. This is 1 again.
Yes, sir.
So 5c0, the first binomial coefficient will always be 1. The last binomial coefficient will also be equal to 1. Clear?
Okay, sir.
NC1 is equal to NCN minus 1 is equal to n. Okay. What is NC1? NC1 means simply starting with n, you write only one number, right? This is very easy.
N.
Now, NCN minus 1 is difficult to calculate by the shortcut, do you see? Because starting with n, you have to write n minus 1 numbers, right?
Yes, sir.
See, among 5c1 and 5c4, using shortcut, which is easy to find.
5c4.
No, 5c1 is easy to find, right?
Yes, sir. Yes.
Starting with 5, you write one number.
Yes, sir.
Yeah, 1 second. Someone is raising hand. Yeah. Beta? Yeah, beta. Someone is raising hand. Yeah, can please speak up. You can speak up if you want. Okay. See, someone has asked me to derive binomial expansion. Okay. See, I am not going to derive binomial expansion. Please understand this. Okay. Because we are at a time crunch now. Okay. It might be, you might be seeing this derivation afterwards. Okay. Who is teaching you now?
KSR, sir.
Right. So you can ask him for derivation if you want. Okay. Right now I'll just keep on going through the important points. Okay.
Okay, sir.
So the derivation of binomial theorem depends on the concept of combinations. You have to complete permutations and combinations to understand the derivation of this. Okay.
Okay, sir.
So NC n minus 1 is n factorial by n minus of n minus 1 factorial into n minus 1 factorial, right?
Yes, sir.
So this is 1 factorial, no? N minus 1 factorial. 1 factorial is 1. N factorial can be written as n into n minus 1 factorial, right?
1 factorial.
N, you see?
Yes, sir.
So 5c1 will be equal to 5. 5c4 will also be equal to 5. You see?
5. Yes.
And the third important property is that NCR is equal to NCN minus 1. Okay?
Okay, sir.
Yeah, beta. Yeah, I'll tell you where to get the notes after the class. Okay? So please be with the class. Okay, once the class is over, I'll tell you where to download the notes from. Okay. So NCR is equal to NC n minus R. What is the meaning of this? For example, 10C3 is same as 10C 10 minus 7. Do you understand?
Yes.
The binomial coefficients equidistant from starting and end are same. See, this is 1, right? 10C0 is equal to 10 minus 0. Is it?
Yes, sir.
10C0 is same as 10C10. For example, 10C1 is same as 10C10 minus 10C9. Okay. The is 5C5. 5C1 is same as 5C4. 5C2 is same as 5C3. So among 5C2 and 5C3, which is easy to calculate by shortcut? 5C2, right?
Yes, sir.
5C2, I won't be writing 5 factorial by everything. That's waste of time. How do I do 5C2? Starting with
5 into 4 by 2 factorial.
By 2 factorial is 2. So 10 is the answer. You see?
Yes, sir.
So if 5C2 is 10, 5C3 is also 10. You see? If 5C2 is 10, 5C3 is also 10. NCR is equal to NC n minus R. Okay.
Yes, sir.
For example, 100C5 will be equal to what? 100C?
95.
If 5 plus 95 gives you 100, they will be same.
Okay, sir.
If NCX is equal to NCY, this will imply X is equal to Y or X plus Y is equal to N.
N.
Is it okay?
Yes, sir.
So now, just we have done one set of theory, okay? We have done the expansion. We have done how to find the binomial coefficients, right?
Yes, sir.
Some of the important properties of binomial coefficients. Okay. So let's take a pause here. Please note this down. Okay. So I'll give you 5 minutes. So please note this down nicely. All of you. So those of you have already noted this down, just revise them so that you remember directly in the class. You don't need to go back and study. The first revision will be over in the class itself. So all of you, do you feel that you have understood something before going forward? Neha? Yeah, fine.
Yes, sir.
So just if you see the binomial expansion now, once you understand the binomial expansion, the second part will be to analyze what happens if you apply this binomial expansion in different cases. Okay. So all of you noted this down? All of you, did you note this down? Can I move forward?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, Satish, done? So now, next is, okay. So some sample questions, very easy questions, okay. What is x plus y whole to the power 7? Okay, let us just quickly write the expansion of this, okay. So it starts with 7c0 x power 7, right?
Yes.
7c1
7c1
x power 6y.
x power 6y.
Yeah, you tell me.
7c2 x power 5 y square. 7c3 x power 4 y cube. 7c4 x cube y power 4. 7c5 x square y power 5. 7c6 x y power 6. 7c7 y
Yeah.
power 7.
Right. Now, let us quickly find the results, okay. 7c0 and 7c1 are 1 and 1, right?
Yes, sir.
Y power 7, okay. 7c1 and 7c7,
Yes, sir.
is it?
Yes, sir.
Now, what is 7c2?
7
Starting
into 6
right
by
two numbers,
2.
find how much?
21.
The last number is also 21, right?
Yes, sir.
Yep. Next, what is 7c3?
7 into 6 into 5 by 3.
3 factorial, right?
Yes, sir.
The last number, this also will be same, right? 35.
Yes.
So how easy this is?
Yes, sir.
All of you, do you see the easiness by which we can expand x plus y whole power n? If you find the first half of the quotient, the second half of the quotient will be directly reproducible, okay?
Yes, sir.
Next question. X plus 1 by x square whole power, okay?
Five c naught x power 5.
5c0 x power 5 it starts.
5c1 x power 4 1 by x square.
1 by x square, okay?
5c2 x cube 1 by x square whole square.
1 by x square whole square.
5c3 x power x square 1 by x square whole cube. 5c4 x 1 by x square whole power 4. 5c5 1 by x square whole power 5.
Is it done?
Yes,
Okay.
sir.
Now, let us quickly find the coefficients. 5c0 is 1, right?
1.
And last, this is also 1. So
1.
this is 1 by x power 10. Okay, last.
5.
5 x power 4 by x square is 5x square, right?
Yes, sir.
Here, x by x power 8.
5 by.
Is it okay?
Yes.
Next, 5c2. How much?
5 into 4. 10.
10. Very good. So you are getting the whole of it, okay?
10 by x.
Plus this is also 10, right? Next one.
Yes, sir.
By x power 4.
Yes.
Done.
Yes, sir. Done.
See, in this, what is the difference between the first and second? In this, x and y are independent variables. That's why we cannot combine x and y. X power 4 into y cube is you just have to leave it there. If the first and second terms have the same variable, then what happens? They can be simplified further, right? You see,
Yes, sir.
if the first term and second term have the same variable, the variables will get cancelled and you get the effective power. You see? Is it okay?
So
2x minus 1 by 3x whole power 4, for example. 2x plus 1 by 3x whole power 4.
4c 2x whole power 4c1 2x whole cube 1 by 3x 4c2 2x whole square 1 by 3x whole square
Right.
4c3 2x into 1 by 3x whole cube 4c4
1 whole
into
cube.
1 yes 1 by 3 whole power 4.
So 4c0 is 1, 4c4 is 1, right?
Yes, sir.
So you get 16x power 4 in the last 1 by 81x power 4, right?
Yes, sir.
Next, 4 into 2 cube. 4 into 2 cube is 8.
32.
32 by 3. X square, do you see?
Yes,
X
sir.
cube by x is x square. 4c3 is also 4. 4
Yes.
into 2. 8 by 27 x cube.
22.
Okay. What is 4c2?
6.
6, right? 4 into 3 by 2, 6.
Yes, sir.
6 into 4, 24. 24 by 9. 24 by 9. 8 by 3, right?
Yes, sir.
X square and x square gets cancelled, okay?
Okay, sir.
Okay, do you see something interesting here? When you expand this, you get different terms, right? In each term, the power of x is different, do you see?
Yes, sir.
And all the power of x's are not coming. You see this? I think we have gone somewhere wrong. X by x is x square, right? Not x cube. Is x square, okay? See, every power of x is not coming. Do you see? X power 4 has come, but x cube has not come. Do you see?
Yes, sir.
See, if I ask you what is the coefficient of x cube in this expansion,
0.
the answer is 0. Do you understand? That means in the binomial expansion, if the x cube term did not come, that means the coefficient of x cube is 0. Do you understand?
Yes, sir.
Now, this 8 by 3 doesn't have any x here. What does it mean? This is a constant term in the expansion. This expansion has a constant term. Do you see?
Yes, sir.
Sometimes you'll be asked to find the constant term in this expansion. The constant term in the expansion is the term corresponding to x to the power 0. Do you see?
Yes, sir.
Do you see the powers of x's here? 4, 2, 0, minus 2, minus 4.
Minus 2.
1 by x square means x power minus 2, right? 1 by x power 4 means x power minus
Yes,
4.
sir.
The power of x's are in repeat. Here also see 5, 2, minus 1, minus 4, minus 7, minus 10. Are they in AP or not?
Yes, sir.
Common difference is minus 3, right? They are decreasing. You see?
Yes, sir.
See, sometimes you might be asked to expand the complete binomial. Otherwise, you may be asked just the constant term. What is the constant term in this expansion? Okay,
8 by 3.
8 by 3, right? So if you just ask the constant term, is it required for you to expand the complete thing?
No.
Maybe not, right? Maybe there is a way in which you can find only this term, right?
Yes, sir.
So thus that process is very important, okay? If I ask you to find the x power 3 to understand that it is not there is very important. You see? So now what we do is we take some corollaries, okay? What is meant by corollary? I always used to get confused when I am in lower classes. How many of you know it? All of you would have heard this word, right?
No, sir.
Yeah?
No, sir.
No?
No, sir.
No, sir. We don't know.
Sir, the opposite of theorem, right?
It's not the opposite of theorem, it's the sub-theorem. Get out of a theorem, but not always. Once you have a main theorem, from that main theorem, you can deduce some logical conclusions, right? By simply slightly changing the theorem, right? Those are called corollaries, okay? See here. These are interesting. X plus y whole power n. See, I am writing this again and again so that when you write it again and again, you'll directly be able to remember. I also get bored writing it again and again, but I'm still writing it. So even, I think you also will get bored, right? Writing it again and again. Yes or no?
No, sir.
So even if you get bored, write it down so that remember it right now. Okay. This is the expansion. Okay. What is x minus y whole power n? See, x minus y whole power n is nothing but x plus of minus y, right?
Yes, sir.
So in the place of y, you get minus y, right? That's it. Now what happens when you raise minus y to different powers? If the power is odd, minus will be left out, right? If the power is even, the minus will get cancelled. Is it okay?
Yes.
Is it okay or not?
Yes, sir.
What you get is NC0 x. Second term, you'll get a minus outside. Minus NC1 x power n minus 1 into y. Okay?
Third term positive.
Third term positive.
Again negative.
Negative. You see? So on. Plus minus so on. Okay?
Yes, sir.
So will the last term be positive or negative?
Depends on equation.
And okay, the last term will be minus 1 whole power n whole power n, right? You see? The place of y you take minus y, right?
Yes, sir.
So what is minus y whole power n? Minus 1 power n into y power. Is it okay?
Y. Yes.
If n is even, the last term is
Negative.
no positive. Because minus 1 whole power n, right? If n is even, minus 1 whole power n.
Okay. Yes, sir.
If n is odd,
Negative.
the last term is negative. You see? Is it clear?
Yes, sir.
Now, what happens if you add these two? What happens if you add these two?
Only even term.
X plus y whole power n plus x minus y whole power n is equal to the NC1 and minus NC1 terms gets cancelled, right? It will be 2 times
NC0 x power n. NC2.
right?
NC4.
Plus so on, whatever is the last term, okay? If n is odd, the last term will be cancelled out. If n is even, the last term will be left. Okay? What is x plus y whole power and minus x minus y whole power? Odd terms will be left out, right? This time.
Yes, sir.
Explain the third example once again in short. Okay. Is it okay? Is this okay?
Okay, sir.
So, who wants me to explain the third question once again? Please raise your hand. Can you please raise your hand, beta? Rupesh, are you the one? Who wants me to explain the third question again? Can you please raise your hand? Okay. Yeah, Venkat. You? See, third question is very simple. Something plus something whole power 4. I have done the expansion and I have found the coefficients. Okay. In this question, 4C0, 4C1, 4C2, 4C3, 4C4. These are the binomial coefficients. This 16, 32 by 3. These are not the binomial coefficients. Do you see?
Sir, can you please increase the font size, sir?
Should I increase the font size or reduce the font size?
Increase. Yeah.
Is okay?
Yeah. Okay, sir.
See, please note this link. Okay, please note this link, all of you. Please note this link, all of you. Is it visible on the screen?
No, sir.
No, sir.
No, sir.
Yeah.
No.
Not at all, sir.
No, sir. No, sir, not.
Now is it visible?
Wait, sir.
Is
Yes,
it?
sir.
Yes, sir.
సార్ అట్లా రాదు సార్ మాకు లింక్
Yeah,
ఇట్ విల్ కమ్.
yeah, it will come. Please note this down. It will
నో
come.
సార్, ఇఫ్ యూ షేర్ ఓన్లీ ఇట్ విల్ కమ్.
Yeah.
Sir, share to
Alright,
any
I'm
group
saying,
or
please
Telegram
note
group,
this
sir.
down.
షేర్ టు టెలిగ్రామ్ సార్.
Please note this down. Okay.
నో సార్, ఇట్ వోంట్ కమ్ ఇఫ్ యూ.
Share this to principal, sir. We can get.
సార్ ఇట్ వోంట్ కమ్ సార్.
I'm asking you to note this down. Please note this down. Okay.
సేవాగ్.
Okay, sir.
So just type this. Okay. A drive will be opened. Okay, this is a Google Drive.
Sir, yes, it came, sir.
Okay, a drive will be opened.
Yeah, it's working, sir.
Okay.
Yeah, it's working,
And
sir.
in that drive, I will create a folder. Okay. Senior incoming. And in that folder, I'll upload these notes. Okay. That is how you download the notes after the class. Okay. Done.
Yes, sir.
bit.ly Lee Narayana without space. There is no space in between. Narayana notes. Okay. Next. What is the expansion of 1 plus x whole power? Okay. See, if it is 1 plus x whole power n, it is nc0. The first term will be 1 power n, right? Yes or no? The first term will be 1 power n, right? Clear?
Yes, sir.
1 power n is 1 itself, no? We don't need to write that, right? It is
Yes.
simply nc0, right? And the next term is nc1. The power of 1 decreases, but it is still 1 only, no?
Yes, sir.
And the second term will have 1 power x plus nc2 into x squared is
X square.
nc3 into x cubed is
X cube.
plus so on up to npn into x power n. That's it. What is 1 minus x whole power n? It is nc0 minus nc1
Minus
x.
nc1x plus nc2 x square minus nc3 x cube
Okay, plus minus so on
minus 1 whole
minus
power
1 whole power n ncn into x to the power n.
x
Okay.
square.
Clear? And again, the last term will be positive if n is even. The last term will be negative if n is
N is
odd. Okay?
odd.
Now the same process can be done. Okay, for these two also, addition and subtraction. What is x plus 1 whole power n? This time you start with x power n. Is it? The power of x has decreased. Do you see?
Yes, sir.
Up to ncn. This ncn will not have any x power. The x will be completely separated, right? X minus 1 whole power n is NC naught x power n minus NC1 x power n minus 1. Yeah. Minus NC3 x power n minus 3 plus minus 1. Banu Prakash, mute yourself and speak.
Sir, mute also.
I want students to respond easily.
Keep
That's
one
why
or two, three students unmute, sir.
Yeah.
One or two students unmute, sir.
Okay. So minus 1 whole power n into NCn. Is it okay?
So 1 plus x or x plus 1 both are same only.
Yeah, both are same. Just the writing of the expansion will be different. You know that the coefficients from the starting and ending are same, right?
Yes, sir.
So effectively it will be same.
Okay.
One is writing in the forward direction, other is writing in the backward direction. Do you understand?
Okay, sir.
Is it clear?
Yes, sir.
See, what I want you to understand is whenever you have 1 plus x whole power n, the powers of x slowly increase. When you have x plus 1 whole power n, the powers of x slowly decrease. Do you see?
Decrease.
Okay. Now, okay. Each time when you write NC1, NC2, NC3, NC4, okay, we are lazy fellows, right? All of us are lazy
Yes, sir.
fellows. No? Yes.
Yes, sir.
Yes, sir.
Okay.
Yes, sir. Sure,
We have a
sir.
holiday. What do we do?
We will sleep, sir.
We'll sleep, right?
Yes, sir. No doubts.
So mathematicians are also very lazy fellows.
And that answer.
What they do is they try to create shortcuts. Okay. So NCR, why to write n every time? NCR can be represented by CR. Okay. Whenever I write CR, it means NCR. Okay.
Okay, sir.
Why to write n each and every time? Okay. Clear?
Yes, sir.
From now, if I write C1, it is NC1. If I write C2, it is NC2. Okay. Is it okay or not?
Yes, sir. It's okay.
Yes, sir.
Now, see, we have understood the basics of binomial expansion. So it's time for you to note these down. We have noted it up to here, right?
Yes, sir.
Just take a few minutes to see these questions once before going forward. Okay, take some breaths and try to see the questions which are done. Are they okay or not? Are the questions okay? All of you?
Yes, sir. Yes, sir.
Next, are the corollaries okay? I have done 3 types of expansions. One with x and one with
It's
one and
better
x,
to
not
change
x.
background color, sir, to look
Yeah.
more brighter. It is better to change background to
You
look
want
more
black?
brighter. Yeah.
Sir, to change it to black, sir.
Yeah, black is better, right? Than white.
Yes, sir. It will look somewhat brighter than.
See, actually, is the pen color the problem? It's okay, right? Usually I do
Yes, sir.
other
In color, it's okay, sir.
yeah, I
Not
do
a
the same
problem.
thing in other classes. People like this color.
It's better to change background color.
Background color, I don't have much options, but either it will be black or white. White will be
You can
stressing
shift
your eyes.
to black, sir. Black or white. Yeah.
Yeah.
Better you choose white, sir.
White will be straining your eyes better. Some students like black than white.
It's okay, sir.
It's okay, sir. Your wish, sir.
Excellent, carry on.
It's okay, sir.
I think
is better, sir.
writing green will
Sir,
be
one
better.
scroll up, sir.
Yeah, sir. Change
Sir,
color,
one
sir. That's it.
Sir, take blue, sir.
Thank you, sir.
Yeah, okay. So shall we go forward? Now comes the important formula, okay? The
Use
important
more color,
formula
sir.
is
It will look brighter.
general term. Is this okay? Better?
Yes, sir.
General term in the expansion of x plus y whole to the power n. Okay. This is the most important one. This is the easiest one and the most important one. Okay. What is the general term in the expansion of x plus y whole power n? So again, I am writing x plus y whole power n. Okay. NC naught x power n plus NC1 x power n minus 1 into y, NC2 x power n minus 2 into y square plus so on, NCn into y to the power n, right? So
Yes, sir.
this is T1, this is T2, this is T3, right? Do you
Yes,
see in T1 it is NC0, in T2 it is NC1, in T3 it is NC2. Do you see?
yes, sir.
So what is TR? It will be NCR minus 1, right?
Yes, sir.
Yes or no? Whatever is here, it is in the power of the second term. Do you see? Y to the power R minus 1. Whatever is this number that goes to the power of y, do you see? NC1 y power 1, NC0 y power 0, right? NCn y power n, right?
Yes.
And the sum of these two powers is always equal to n. Do you see? The sum of powers of x and y is always equal to n. So if it is y power r minus 1, it should be x power
X power
n
R.
minus r plus 1. Do you see?
Mm.
Such that the sum of the powers is equal to n. Is it okay?
Oh, yes, sir.
This is the general term, but I am not happy with this. This looks very clumsy.
Sir, can we convert into P and C? Permutations and combinations.
I am not happy with this. What I do is, instead of TR, I'll write TR plus 1. What is TR plus 1?
TR plus 1 minus TR. NCR.
NCR, right?
Yes,
If
sir.
TR, you get NCR minus 1. If you want TR plus 1, it's NCR, right? Y to the power
Yes.
R. X to the power n minus R, right?
And
Does
Y
this look
power
good?
R.
Does this look good? I think
Yes,
out
sir.
of the first formula and second formula, which one do you prefer?
Second.
First one,
Okay.
sir.
Second one.
So usually the mathematicians who have done this, have developed this theory, have preferred the second one. Okay. I also personally prefer the second one. It's easier to manage. Okay. So what is the formula for general term? The general term is given by TR plus 1 is equal to NCR x power n minus R y to the power R. You see? This is the general term. Is it okay? Clear?
Yes, sir.
R starts with which number? R starts with 0. Okay. If you put R equal to 0, you get the first term, T0 plus 1. If you put R is equal to 1, you get the second term. You see? Is it clear? So x plus y whole to the power n, the general term is NCR x power n minus R y to the power R. Okay. What do you think is the general term is x minus y whole power n? It will be minus 1 whole power R NCR x power n minus R y power R. Do you understand why this number comes?
Yes, sir.
Why?
If it is odd, it will be negative. If it will be
So because actually instead of y you get minus y, right? So minus y power R is minus 1 whole power R into y power R. You see? Clear?
Yes.
What is the general term in 1 plus x whole power n? NCR
Y power R.
x power R. first term is 1, no? This becomes
Yes.
1. So x power r. What is the general term in 1 minus x whole power n?
-1 whole power r NCR x power r.
Clear? What is the general term in x plus 1 whole power n? NCR x power n minus r. Do you see? This time y is 1, right?
Sir, can you please explain this blue part again, sir?
Yeah, which one?
Blue part, sir.
Blue part means from the starting or?
From star mark, sir.
Yeah?
Sir, from star mark, sir.
One second. See, I am writing the general terms. Did you understand the previous concept? This one?
Yes, sir.
See, did you understand the meaning of general term?
Yes, sir.
See, if you write T1, T1 has NC0, right? T2 has NC1, right? T3 has NC0, right?
Yes, yes, sir.
TR will have NCR, right?
Yes, yes, sir.
And whatever is here, the same thing is carried out by power of y, right? So if it is NCR minus 1, y will have power of r minus 1.
Yes, yes, sir.
And the sum of the powers of x and y will always be equal to n.
Yes, yes, sir.
So, if it is r minus 1, what is this? The n minus r plus this.
Yes, yes, sir.
But this will be what I write is instead of TR, I write TR plus 1. What is r plus 1? You'll have NCR.
Yes,
If it is
yes, sir.
r, it is r minus 1. If it is r plus 1, it is r. Here. Y will have power and x will have power minus 1. Okay? That's a general.
Yes, yes, sir.
Is it clear?
Yes, yes, sir.
I am applying it in different places. Is it okay?
Thank you, sir.
So some questions in x plus y whole power 10. T7 is equal to what? In 3x minus 1 by x whole power 9. T4 is equal to what? In 1 minus 1 by x square whole power 5. T4 is equal to what? Something like this. This half portion is these questions can be solved through the concept of general. Okay. Here, the complete expansion is not being used. See, the complete expansion is not being asked. Why should we do a complete expansion? T7 is 6 plus 1. So it is 10 6. The second term power 6. The first term power 10 minus 6. Is it okay? Is it okay? Yes, sir. T4 is T3 plus 1, right? T4 is T3 plus 1, right? So what is it? 9 is 3, right? The second term is minus 1 by x, right? Power 3. The first term, 3x power how much? 3x power how much? The sum of powers should be equal to 9. Should be 6, right?
Yes, sir.
Is it clear or not?
Yes, sir.
What is T4? T3 plus 1, right? 5, 6, 3.
Minus
1 by x square whole cube into 1 power 2. You don't need to write it. Can skip it. Is this understood? So how do you find 10 60? 10 6 is same as 10 4, right? 10 6 is same as 10 4, right?
Yes, sir.
Starting with 10, write 4 numbers.
By
Write 4
4.
factorial. 4 2 8. 3. See 2 10. Is it quick or not? Is it clear?
Yes.
93. Starting with 9. Right? 3 numbers. By 3 factorial. 3 3s are 2 4s are. So 28 into 3. How much? 82. Right? 5 3 same as 5 2. Right? 10.
Yes.
Is it okay? So if you are asked to find any particular term, can you do it or not? If you are asked to find any particular term, is it okay or not?
Yes, sir.
Okay, sir.
Okay, sir.
Next question. This is the important question for you. Okay. Let me write it. Find coefficient of x power 7 in 2x square plus 1 by 5x whole power 11. Okay. Coefficient of x power minus 7 in x minus 2 by x square whole power 9. Constant term in 3 by 2 x square minus 1 by 3x power 9. Fourth, x power 8, coefficient of x power 8 in 2x square minus 3 by x whole power 9. Okay, these are the 4 portions. See, you are not asked to do the complete expansion. Okay, you are just asked to find the coefficient of one given power of x. Okay, this is what do we do here? 2x square plus 1 by 5x power 11, right? All these questions are solved using the concept of general term. What is the general term of this expansion? 11 CR, right? Can you tell me? 1 by 5x power? Anybody? 1 by 5x power? How much?
R.
R, right. Into 2x square power how much? 11 minus R, right? So
Yes.
that is equal to. Now this is both these terms are dependent on each other, right? Both are the same variable. This is 11 CR. Now let us separate the coefficient for 11 minus R by 5 power. That is a constant. Let us combine the x power 22 minus 2r into x power minus r. Is it? Okay or not?
Yes.
11 CR 2 power 11 minus r into 5 power x power 22 minus 3r. That means in 3r plus 1, the power of x will be this. Do you understand? That means if you put r equal to 0, the power will be 22, right? If you put r equal to 1, that is in the second term, the power will be 22 minus 3. You understand? You understand this?
Yes.
Now, what is the coefficient of x power 7, right?
R equals to 5.
Yeah, our coefficient of x to the power 7 is 22 minus 3r equals 7.
Yes.
So 3r should be equal to 15. R should be equal to
5.
5. You see? That means when R is equal to 5, coefficient of x, the power of x will be equal to how much? 7, right? So the corresponding, you don't need to find all the terms, just find the corresponding term. What is the term? T5 plus x, just T6, okay? Is equal to 11 C5, right? So, 2 power 11 minus 5 is how much? 6 by 5 power 5, right? Into x power 22 minus 15 is 7. So what is the coefficient of x power 7? This is the answer. Okay, many times you don't need to simplify it. The answer will be like okay. Yeah, when I go.
So what show from star mark?
Show from
Star mark.
star mark. Where is the star mark? Very yeah.
Yes.
You want to take screenshot?
Yes.
See, others do the same process and do second and fourth question.
Sir, scroll a little bit down.
Down means you want to see the solution.
Yes, sir.
See, others, please solve all these four questions. What is the meaning of constant term? What is the power of x? What should equal to the power of x?
0, sir.
Yeah, it should equal to 0. So please do all these questions. Yeah, beta.
RB fraction.
No, that's the thing in the fourth question. Okay, in the fourth question, when you solve, R will not be a good number, right?
In second one also R is fraction.
Okay, in second one also R is a fraction. So if you don't get a good number for R, that means that particular coefficient is not present. You understand? We have seen that any given power of x may not exist. So if you take this TR plus 1 is equal to 9 CR minus 2 by x square whole power r, x power 9 minus r. The power of x will be 9 minus 3r. If it is equal to minus 7, 3r is equal to 16. R is equal to 16 by 3. Not possible, you see? Because R is the rth term, right? You cannot have fractional term, you see? So what is the coefficient of x power minus 7? Is equal to 0. If the term is not present, that means the coefficient is 0. You see? Okay.
Yes, sir.
Is this okay? Say anybody wants me to do any question, please tell me. Please raise your hand. Yeah, Chanakya, I remember you. Chanakya, you are there in the class, right?
Yes, sir.
So can I go forward if you understood this?
Yes, sir.
What is key for
But fourth one also I hope you get a fractional.
yes. Yes, sir.
Fractional, right?
Yes, sir.
So the coefficient is 0. Here you will get something in the third question.
R equal to 6.
In the third question, R equal to 6.
Yes, yes.
Yeah. So you get the constant term also, right? So you can calculate. If you put R equal to 6, you calculate the term, that is a constant. Shall we go forward?
Yes, sir.
So now using this, you can do another type of question. Okay. The other type of question that can be asked is finding number of rational terms. Finding number of rational terms. Finding the number of rational terms. Okay. For example, question is like this. You have 3 power 1 by 5 plus 2 power 1 by 3 whole power 15. Find the number of rational terms in this expansion. Okay. So by the way, did you observe this? Did you observe this result? X plus y whole power n has dash number of terms. So how many terms will x plus y whole power n have?
N plus x.
It has n plus 1 terms. Yes, sir. It has n plus 1 terms, right? For example, if you expand this power 15, you will get 16 terms. Okay? Out of those terms, how many rational terms are there? See, how do you solve this? Just write the general term. TR plus 1 is equal to 15 CR. 2 power 1 by 3 whole to the power of 3 power 1 by 5 whole power of 15 minus r. So if you look at it carefully, it is 15 CR. 3 power 15 minus r by 5 is 3 minus r by 5 is into 2 power r by 3 is it. Now you see that if the number, if the term has to be rational, it should not have irrational terms. Right? If you have fractional powers, those are radicals and those are irrational. So, for example, 2 has, if r is equal to 1, 2 power 1 by 3 is cube root of 2, which is an irrational number. Right?
Yes, yes.
So P R plus 1 to be rational, what should be the case? R should be a multiple of 3, right? And R should also be a multiple of 5, right? R should be, or I'll write R by 3, R by 3 and R by 5, both of them has to belong to integers, right? So,
Yes.
this implies that R should be a multiple of
3 and
R should be multiple of 3 and 5. Do you see? R should be a multiple of 3 and 5, right?
Yes, sir.
Is it okay?
Yes, sir.
Is it clear?
Sir, is it 15?
So R should be a multiple of 3 and 5, right? And R can go up to only 15, right? R goes from 0 to 15, right?
15 and 15.
So from 0 to 15, how many multiples of 3 and 5 are there? So R can be either 0 or 15, right? Only one.
Yes, yes, sir.
So this implies 2 rational terms. Is it okay?
Yes, sir.
And how many irrational terms?
30.
How many irrational terms?
14.
14.
Because the total number of terms is 16, right? Is it okay? Is it okay or not?
Yes, sir.
Yes, sir.
Is it done? So this type of question is also okay, right?
Yes, sir.
Next is finding rth term from end. Finding rth term from the end. See here, in the previous question, I have asked you to find some particular term. You are able to find it, right? For example, I have asked you to find T7, T4, T4. You are able to find it, right? So how do we find rth term from the end? For example, find the 10th term from the end. 10th term from the end in 2x minus 3 by x square whole power 26. Okay, some question like this. Is it okay? So what is the logic here?
Minus R plus S.
Yeah, so TR from the end. See, let us take a pattern. Okay. See, T, if you have, suppose that there is x plus y whole power. Okay. Let us observe this pattern. Let us take x plus y whole power. Correct. There are n plus 1 terms. Right. So T n plus 1 is the first term from the end. Is it? N plus 1 is the term from the starting is the first term from the end. Right? Is it? Tn will be the second term from the end, right? Is it?
Yes, sir.
Yes, sir.
T n minus 1 will be the third term from the end, right? So, is it okay? So do you see any pattern here. This plus this is always equal to n plus 2. So R term for the end will be equal to T n minus R plus 2 from the starting usage.
Yes.
Is it okay?
So not in
What I'm doing is I'm trying to understand the pattern. In x plus y whole power n, there are n plus 1 terms. Is it okay? In x plus y whole power n, there are n plus 1 terms. Okay?
Yes.
So what is the n plus 1 n left? That's the last term.
Yes.
So that is the first term from n.
Yes.
Nth term will be the term before it. That will be second term from here. N minus 1th term will be the term before that. That will be the third term from here. So if you see the pattern, what do you observe? This plus this is always equal to n plus 2.
Yes, sir.
So what is TR from the end? It is T n minus n plus 1 from the starting base. Is it okay?
Yes, sir. Understood.
For example, if you want, for example, you take this question, okay? Take this question. We have a question right already. I want, what do I want? I want T10 from the end, right? Is it? This will be T. See, whatever you write here, it should be, the sum of these two should be n plus 2. N plus 2 is 28, right? You see? So T10 from the end will be T18 from the start. Do you see? Or if you want to write it, 26 minus 10 plus 2. That is equal to 28. Okay.
Yes, sir.
Is it okay? See, you don't need to remember this. Can you write this pattern by yourself when a question of this is asked? Can you write this pattern for yourself?
We can.
You can write it, right? And you can clearly observe the sum of these two should be n plus 2.
Yes, sir.
So how difficult is it? It's easy, no?
Yes, sir.
T18 is T17 plus 1, right? TR plus.
Yes, sir.
So 26 T17 minus 3 by x square whole power 17. 2x whole power 26 minus 17 is how much? 9, right? Is it okay or not? See, don't need to remember a lot of things. Most of the things will be easy if you apply your common sense. See, personally, I don't remember this. That's why I have derived this. You see, whenever someone asks me the RF term from the end, I'll just write T n plus 1 is T1 from the end. Okay, the sum is n plus 2. So, whatever you write here, the sum of these two should be 26 plus 2, 28. So, I get 18. You see? Yeah, better. You want me to scroll up?
Sir, he is saying one more example.
One more example. So this time you decide the example. Okay? You decide the second. Find 24th term from the end in
So take from starting.
x minus x plus 1 by 2x square whole power 73. Okay. So T24 from the end will be equal to T. How much from the start?
75.
Whatever you write here, the sum should be 75. 51. That's it. T51 is T50 plus 1. So 73 is T50. 1 by 2x square whole power 50 power 23. Done. You see? Okay. Is it okay? All of you, is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Sir, one scroll down, please.
Which question? These two questions.
Yes, sir. Okay.
So this is what we have here, right? What is TR plus from the end? T. Does it make sense?
N minus R plus 1.
Correct. No? TR plus from the end is T and minus R plus from the start. Is it okay? See, you just have to ensure that the sum of these is and that's right. Is it clear?
Yes, sir.
The last topic for today, middle term. Last topic for today is middle term. See, this is also very straightforward. X plus y whole power. For example, if you have 5, okay, x plus y whole power 6. If it is n, you'll have how many terms? You'll have 6 terms, right? If the number is odd, you'll have even number of terms. If the number is even, you will have odd number of terms, right? Done. Understood?
Yes, sir.
If there are odd number of terms, there will be one middle term.
Yes, sir.
If there are even number of terms, there are two middle terms. Okay. See, this is 6C not term, 6C1 term, 6C2 term, 6C3 term. 5, 66, right?
Yes.
So see here, I am writing it by pattern. No theory is required. Middle term in x plus y whole power n. Okay, is there are two cases. If n is even, okay. If n is even, there will be one middle term, right? It will be nc n by 2, right? You see, if it is 6, it will be 63. Okay. Yes or no? It should be nc n by 2, right?
Yes, yes.
nc n by 2. If it is n by 2 here, y will have power n by 2. And x also will have n minus n by 2, which is n by 2.
Yes.
And this is t n by 2 plus 1. You see?
Yes, yes.
And the fourth term, n by 2 is 3, t3 plus 1. The fourth term is the middle term. Is it okay? So I hope this is straightforward. Nothing much right.
Yes, sir.
If n is odd, there are two middle terms. This is 5C0, 5C1, 5C2, 5C3, 5C4, 5C5, right? Obviously, this time NC n by 2 cannot be written. Yes, because n is odd. So I will add 1 by 2. Okay. So what comes? 5 plus 1 by 2 is this one, right? And how do you get 5C2 term? It is NC n minus 1 by 2, right? So this 2 is 5 minus 1 by 2. This 3 is 5C n 5 plus 1 by 2. You see? See, if n is odd, because we cannot directly divide by 2, we add 1 and divide by 2, we subtract 1 and divide by 2. Is it okay?
Okay, sir.
Okay, sir.
Now, what will happen? This y will have power n plus 1 by 2, right? X will have power. The sum should be equal to n, right? N minus 1 by 2. You see? Here y will have power n minus 1 by 2. X will have power n plus 1 by 2. You see? Is it okay? This is t n plus 1 by 2 plus 1. N minus 1 by 2 plus 1. Is it okay? That's it. This is the theory of middle term. So is it okay?
Yes, sir, it is okay.
Yeah, it's fine.
Fine, sir.
For
Sir, this
example, you have x square minus 2 by x cube whole power 9. Okay? You want the middle term.